All right, welcome back. So I hope you've had a chance to try these two exercises. I'm going to go over solutions now, so you can follow along and check your work. So first, for this first one here with y equals 2 times cosine of 4/3 x plus 2 pi over 3, in this one, amplitude is going to be 2, and that comes from the a value, that 2 times the cosine. So that's that. Now the period is going to come from 2 pi, going up to our formula here, 2 pi divided by the b value. So that would be, I'm going to put that over here somewhere, 2 pi divided by b, which is 4/3, divided by 4/3. Oof. Simplify that fraction there, and you're going to get 3 pi over 2. So 3/2 pi. I'll put that here. 3 pi over 2. Okay. Now, the phase shift is going to come from c over b. Now, you can see here, I want to interpret this as minus c. So you always want to interpret it as a minus right here. So I'm going to have c equal negative 2 pi over 3. Right here, you see that? Negative 2 pi over 3, because we're supposed to be subtracting. So that means c over b is going to be negative 2 pi over 3 divided by 4/3. Now the thirds are going to cancel out, and you have negative 2 pi over 4, negative pi over 2. So phase shift, negative pi over 2. That means we're going left. Okay, the negative means left. All right. Finally, the midline. You'll notice the plus d, midline is meant to be d, and the plus d on the end is missing. This is basically plus 0. The midline is y equals 0. We get to graph this one right along the x-axis as a midline. Okay, now how to actually graph it. Remember that the regular cosine graph is supposed to start, that's not a great way to try it here. It's supposed to start, it's supposed to cross the y-axis up here at 1, basically like that, right? That's where it starts, right there. So what we want to do is we want to apply our phase shift of negative pi over 2 units to the left. And we're going to take that point that would have been there, and we're going to shift it leftward. So we shift it over here and put it there. Okay, so that's going to be the beginning. Now, if that's our starting point, where are we going to go from there? Well, our period here is meant to be 3 pi over 2, 3/2 pi. So from 0 to 3 pi over 2, that's the length of the period. Shift that over, and it's going to be that distance right there. So this point on the wave should be repeated the period distance further on. So now we get to do something kind of fun, which is we get to fill in the rest of the wave. As soon as you know 2 points on the wave that are a period distance apart from one another, then you can fill in the entire rest of the wave, because exactly halfway in between those is where it's going to reach its minimum value. Oh, which I just realized I'm plotting at the wrong point, because I'm plotting this with an amplitude of 1, but I just remembered the amplitude is supposed to be 2. So let's fix that, okay? And I'll get back to graphing the whole wave in just a moment. So instead of putting our starting point here, we're going to shift it up 2 so that the amplitude is 2. And then this corresponding point is going to be there, 3 pi over 2 units further along. And then the halfway point, if you go exactly halfway between the two peaks, you're going to reach your valley, which should be 2 units down below our midline. So there we go. So now we've got this point, and this point. And then at the quarter points between on the period, so halfway point of the period is where you reach the bottom. At the quarter points, which would be like let's see, here and here, dividing the period up into equal fourths. Halfway between the peak and the valley is where you're going to reach the x-axis, and over here as well is where you're going to reach the x-axis. So we have this perfect, peak, x-axis, valley, x-axis. And then back to peak again. And then we're going to have another x-axis. Let's take the same distance here, which is 3 of these, units. That's where we're going to hit the x-axis, and then same distance further along is where we're going to reach another valley, and then another x-axis point. So it's bouncing back and forth like this at regular intervals. And now you don't want to just connect this with lines like that. That's not what you want to do. Okay, instead what we're going to do is curve it out so it's nice, curves, and it reaches, you know, the curves reaches kind of like valleys and hills. It's a nice curvy sort of wave function. It goes sort of like that. There we go. And we got it. So that's the graph of that particular wave function right there. All right, second one. Here now we have a graph already given to us. And so now what we need to do is figure out all these different values. Well, first the midline is clearly here, right? So now this midline here is at 2. Y equals that down. We have to decide if we were going to do sine or cosine. Cosine, like the previous example, cosine, you know, starts at a P, right? So that would be like here. It's not exactly clear what that x coordinate is, so that would make it difficult to determine the phase shift. So instead of doing cosine, I'm going to do sine, because sine would start here at a point where the graph is crossing the midline and traveling upwards. And that is very clearly at an x coordinate of 1. So that's going to give me my phase shift, which is +1, right, to the right 1 unit. Now the period can be measured by going along to the next point, you know, the next equivalent point on the wave, which would be down here, and that's at 7. So this distance is our period, and from 1 to 7 is 6 units. So our period is 6. Now the amplitude is the distance from the midline up to the peaks and the valleys, and that's clearly 2. So, so there we go. So now we've got our 4 pieces of information. Now we can build the graph. Now we said we were going to do sine, right? Because of the fact that we're doing sine comes from measuring the phase shift to a point that looks like this, okay, which is where the sine function starts. We're going to have a sine function, some stuff on the inside and some stuff on the outside. First of all, amplitude being 2 means we're going to have an a value of 2, which we'll stick right there. Midline is 2 as well, so that means we're going to have a +2 on the end. Let's do the easy ones first. Then, now let's do the hard ones. The period is supposed to be 2 pi divided by b, right? So that means 6 should be 2 pi divided by b, all right? So the period is 6, so we put the period 6 in for the period, and now we have to solve this for b. This means b is going to be 2 pi over 6, or pi over 3. Oops. Sorry, this is difficult to do. Pi over 3. So solving that equation for b, multiply both sides by b, divide both sides by 6, reduce that fraction, got pi over 3. So now I'm going to put pi over 3 as our b value. Pi over 3 times x. Now we have to do minus c. And remember that the phase shift is c over b. So now that we've calculated b, okay, we're going to use that information along with the phase shift of 1. 1 is supposed to be c divided by the b value, or pi over 3. And then that gives us the c value, which is also pi over 3. So solve that for c, and you get pi over 3. So that we would do, since we're moving to the right here, okay, we just subtract that c value, like that. And we did it. So that right there is the equation for this sinusoidal curve, or this you know, wave function. I was flipping up and down to see if there's anything else I wanted to talk about in this video, but I think that is it.